Welcome to my course, Game Development Basics, Week 8, Lesson 7, Haunted House Updates. In this lesson, we'll review the project updates that we made since we left off in Week 4, and a big part of the updates was the implementation of enemies in our world. So I'll demonstrate the AI system, and then I will review the AI implementation. So here we are back in our project, and I decided to go a different direction than the haunted house. I'm now calling my game Invasion, and in this game we're going to have an alien invasion in our neighborhood, and the goal is to escape the neighborhood after killing all of the enemies in the level. So the player is going to need to navigate the level and find various resources that are distributed in the houses. And then at the end of the level, there will be a final battle where all of the remaining enemies will come to the player's location and they'll have to defeat all the enemies. So the goal is to try to kill as many enemies as possible before you get to the end of the level so you're not completely overwhelmed. So here I am spawned into my world and I'm in my house in my game. And if I look outside, I can see some aliens running around in my neighborhood. I can turn off the lights in my room and then head over here where I have a pistol hidden away. And I can go out here and start to engage some of the enemies. And you can see that they're kind of just searching around the level. And they can attack me and I take damage. And here I find a key on this table that I can go into the basement and unlock a door where there's now access to more weapons. And here, when I get to the end of the level, I can see that there's 6 remaining aliens. I now have 2 minutes to kill the rest of the aliens. And when I kill the last alien, the game is complete and I escaped the level. So for the level itself, I actually used an asset pack that had a world already set up in it. So I just made some modifications to it to allow the game loop that I wanted. So there's not a lot to go over there. The biggest change that I made that we haven't already gone over is the implementation of the enemies. And for this, I created an AI system for these enemies so that they could attack the player. So here I have my enemy. This again is from an asset pack that I got off the marketplace. I'll put a link to the asset packs in the description of this video if you want to check them out yourself. This is just of type character and I've added the mesh. I have the animation blueprint set up so that it can walk around in the level. And I've added a BP health component, which is the same one that we used on our player. And we've set up a similar system in our Bug Squash game and in our Space Fighter game. So this should be mostly review. If you need some help getting that set up, I recommend going back to either one of those projects. And for the AI, I've set up my own BP AI controller, and you can see that I've set that to the AI class in the pawn. You can get this in the class defaults. So I've put the AI controller class as BP AI controller, and you also want to set auto possess AI to placed or spawned in the world. For this game, we're only placing them in the world, but if you wanted a system where you could spawn additional enemies, maybe if certain conditions take place, like if they go into a house that you don't want them to, maybe additional enemies spawn in that house, you would want to change this setting. But on this actor, really the only 2 things that we have are when the enemy takes damage, we want them to move to the player and start attacking them. And then we have this event attack that is set up through an interface. And all this is doing is playing an attack montage. And we'll see when we get to the AI that this is being called when we get within a certain range of the player. And when that is complete, we just call a dispatcher that the attack is complete to let the AI controller know that we can proceed back into the AI functionality. So here on our AI controller on begin play, we're just going to get a reference to the game mode, and we're going to bind to an event called unleash, and we'll go over this. But this function on game mode is that the player gets to the end of the level and all of the remaining enemies are going to come after them. We also want to give a reference to a few other variables, the player variable and the controlled pawn, using get controlled pawn and then casting that to enemy base. I'm also getting the actor starting location and setting that as a variable, and we'll use this for the patrol functionality. Then we proceed into an event called AI handling. AI handling is first going to check, is the controlled pawn dead? And if it is not, then we'll go to the next branch, which is whether or not we have called the unleash in the game mode. If this is false, meaning the unleash event has happened, then we'll chase player. Otherwise, we're going to go into the rest of the functionality of the AI. And I think this is a good place to pause for a second and talk about the behavior tree system that exists in Unreal Engine. Now, there is a pretty advanced AI system that is already in Unreal Engine called behavior trees. There are a lot of great content creators that create content for using behavior trees for AI implementation, but I also feel that this is a pretty polarizing topic within the Unreal Engine community. I personally feel that the behavior tree system is not very intuitive to beginners, and I've heard from multiple people that they feel like it just feels a little bit out of place. So whenever possible, I try not to use the behavior tree system. Now, this is not to say it's not a great system. However, my personal opinion is that it just doesn't quite have the same flexibility as using blueprints. Now, in that behavior tree system, there already exists a perception system that you can use to set various perception inputs for your AI. For instance, whether they can see the player, whether they can hear the player, and various other things. What I've done is just basically made my own perception system using blueprints. Now, you don't have to do it this way. If you're interested in learning the behavior tree system, I'll put some links to some content creators that make great content on the behavior tree system, but I'll just show you really quickly the perception system that I made so that we can check if the enemy can see the player. And that's this first branch here, visibility checks. And we'll see that it returns either true or false, whether it can see the player. If it can't see the player, we're just going to have a brief delay, and then we're going to call patrol. And if it can see the player, then we'll call chase player. So here in visibility checks, the very first thing that I need to do is get a 0 to 359 degree bearing. And this is just to make the math a little bit easier when trying to figure out whether or not we're looking at the player. So essentially what we do is we get our controlled pawn, which is this actor, and then we get the player, and we get our find look at rotation. And we're going to get the Z rotation, which is the direction that the enemy is facing. This rotation will return either 0 to 180 degrees or 0 to minus 180 degrees. And essentially what we're doing is converting that to a 0 to 360 degree rotation. So if this Z rotation value is greater than 0, we'll just set it to true bearing. If it's less than 0, we're going to add 360 degrees to it, and this will give us a 0 to 360 degree bearing. And we'll set that to true bearing. Then we're going to set target rotation, and this will give us a relative rotation of where the enemy is currently looking to the player. So we're going to get controlled pawn again, and we're going to get that Z rotation. Then we're going to take true bearing, which is the variable we set here, and subtract that value. Now, if this value is greater than 180, we want to subtract 360 from it, and that becomes our rotation. Otherwise, we just set that as the target rotation. And then the return of this is this AND node. And there's three conditions that we're going to check. The first one is, do we have line of sight to the player? So we can use line of sight 2 with ourself and the other as the player. And this will mean if there's a wall or some other obstruction blocking the enemy's view of the player, will return false here, which would mean this AND gate is going to return false. The next input to this AND gate is whether or not the player is within a field of view of the enemy. And we're checking this target rotation value and whether it is within the range of -90 to 90 degrees. And then what this will do is check if the player is in front of the enemy, we'll get a true, and if it's behind the enemy, we'll get a false. But I also felt it a little bit strange that we could get very close to the enemy from behind and it still wouldn't see us. So I also got a get distance to, and I set a minimum range of 450. And if our distance is less than 450, then we'll also return true here. So these two things basically handle whether we can see the player or the player is close enough that we'd be able to sense it. And the last thing we're checking here is the player within a maximum range so that the enemies can't see the player all the way on the other side of the map. So essentially we're seeing, do we have line of sight to the player? Is the player in front of the enemy or within a minimum range? And is the player within a maximum range? And if all three of those are true, we'll return true here. And if any one of those conditions returns false, this will also be false. So if it is true, we'll call chase player, and chase player will set the actor rotation to look at the player and then wait half a second. This gives us a sense that the enemy has sensed the player and have a brief delay before it starts to move to the player to attack it. And for this, we're just going to use AI move 2, and we're going to move to the player. And we also want to do some checks where periodically we're checking to make sure that we haven't reached a condition where we cannot reach the player. And if we do, we'll just reset back to the beginning. But if we do get within that range of the player, we'll call that attack interface, which again played that attack montage. And then when that montage is complete, it calls this dispatcher. So we'll call a delay of attack frequency, and you can change this based upon how often you want the enemies to attack the player. And then we'll go back to the beginning of AI handling and start all over again. The last thing to discuss is the patrol, and essentially all this is doing is getting that starting location that we set at the beginning, and we're using get random reachable point in radius, and I set a radius of 750 units. So this will give a radius that the enemy can walk around. Now, if you don't set a starting location, they could essentially just wander endlessly within the level. So every time we call patrol, it would get a new location. So if you wanted to do something like that, to have it be a little bit more random, you could instead have the origin be get actor location, and then it would search within 750 units of that location. Then we just use AI move 2. We're doing visibility checks constantly so that if at any time the enemy sees the player, we're going to go to chasing the player. And if it gets to the location, we'll wait a second and then call AI handling. And if for some reason it can't reach that location, we'll just do a brief delay and then call AI handling. And the last thing we want to talk about is just the attack. So we have an notify of attack, and if we see here on this attack animation, that notify is happening here. So when that notify happens, we're going to get pawn owner and cast that to enemy base. And we're going to get this sphere, which we set up here in front of the enemy. And the point of this is to basically check if the player is within this sphere, then we can have them take damage. So we can see that here, we'll get that sphere, and we'll get overlapping actors, and we'll check if any of them are player character. We'll do a for each loop, and then any player character that is in that array will call apply damage, passing in a damage amount. And this is how we're handling the attacking on our enemy. And that pretty much sums up the updates for this project. There was a lot more that we did on live stream, so if you're interested, you can go check out the live streams that I did for this project. There's quite a bit of additional information there and discussions that I had with the community. So if you're interested, you could check those out. Otherwise, in the next lesson, we'll go back to our Space Fighter game and we'll review some of the updates that I made to that game. So I'll see you in the next lesson.